So what are you boys doing? You're building a Moxon today?
We're going to build a Moxon, yeah.
A 6 metre Moxon?
That's right.
And these are the dimensions?
Yes, of the many Moxon calculators on the internet.
This is for the contest, the field day. The
field day.
Why did you pick a Moxon?
Look, we wanted something really compact for the van that we could probably leave on the van all the time. So the dimension of this is going to be about 800 long and 2 metres wide. So it'll sit on the van and can live there sort of all the time.
Oh yeah.
As opposed to like a 3-element yagi would be not fit either way. So.
And the good thing about a Moxon too is the front to back is very good. And where you usually set this up, there's nothing really behind you, is there?
That's right. Yeah. Look, all of the reports and reviews seem to say that they're really good front to back. So.
Yeah. So a Moxon is basically just a 2-element yagi antenna with the ends folded in to save space. So very, very little compact antenna. It's only a reflector and a driven element, and relatively easy to build. I've built a couple of these before out of aluminium, and you can build them out of wire. You can also just string them on, you know, some sort of structure with like fiberglass as spreaders, or just, you know, build up some sort of frame. I know that Chuck KK6USY, he's built one out of PVC frame before, but yeah, they're relatively easy antenna. Not a lot of parts, just a little bits of aluminium, and that's what we're building this one out of today. So a little bit more sturdy, because where we're going to be taking this is up on top of the mountain, which is, you know, pretty rough weather. So
a bit more.
It is pretty forgiving. You can get it. That's one easy way to cut aluminium. So you got the brand new pipe bender.
Brand new pipe bender.
Look at this. So obviously with a Moxon, you've got to bend the ends in to save your space.
Yep.
So that's what you got the pipe bender for.
I did, yeah. Look, it's I think a lot of designs they've used PVC pipe and just had like 1 mil wire either in it or taped to it or stuff. I just think for mechanical stability, it's just nice to be able to actually have an aluminium bit of wire.
It's also it'll hold up a little bit better in the weather as well, won't it?
I think so. Yeah.
Because PVC tends to move about a little bit, and
it does. And we don't need excuses to buy new tools, do we, Hayden?
New tools are always a good thing to buy, aren't they?
That's right. You never have too many new tools.
You can never have too many tools.
That's right. That's right.
Yeah, I'm sure that there's some sort of
the optimum number of tools is very much like the optimum number of radios. It's always n plus one.
I'm sure there's some sort of dodgy joke there, but I don't think we'll tell that, because we're not like that on this channel, are we?
No.
You can't do butt crack jokes either.
No plumbers here.
No plumbers. Whilst you tried to get the bend out of because they weren't bent properly.
Yeah, then we're going to cut it anyway.
You've just cut it in the middle anyway. So
that was an experiment.
That was an experiment.
Right.
We knew that because we wanted to see if we could bend it, because this was always going to be
the driven element.
We did that as an experiment because we thought if we mucked that up, we're going to cut it anyway.
Yeah,
because we had the lengths longer.
Because the reflector, you can't do that.
That's right.
No.
Yeah. So this was a trial run for the reflector, just to check out how much we lost on creep on the bender.
Yeah.
As it worked out, we were a bit inaccurate. We were 0.5 mil out.
Actually, that's a very good point. So with the bend, you've got to take the length of the bend into account.
So you've got to experiment to work out how much it grows.
Yeah, because
the dimensions are to here, of course.
Yes. So you were measuring from there to obviously the other end at the same spot.
Correct.
Yeah. And when you bend the pipe, it can always, it depends on how big your pipe bender is too, because
that's right. Each pipe bender is different. Some of the flash ones, they'll actually document. They actually give you a little instruction, and if you allow this much from this bend, but it's always nice to just bend one and measure it, and you can reproduce that. Quite often you can cheat if you're going to do lots of pipe bending. You can actually bend a little sample piece, and mark both sides of the bend, and then cut it off and use it as a template.
An amateur never has a tool which is designed for its original purpose, right?
Well, this is right. Like let's have a look and see how we went here, Mr. Murray.
Bearing in mind this is for 6 metres, so...
That's right, yeah, we're not building it for 3 centimetres.
No,
we're off our usual build schema here.
This is the she'll be right moment.
Which one is right, Murray?
Oh.
I was just going to get the square out. Oh, look at that, it even clamps in.
Yeah.
So it's got a little clamp.
a little clam.
That's awesome.
It's like a ball one.
Yeah, well.
And you had to go a bit, didn't it? Is that a metric bit or an imperial bit?
We don't deal with imperial here. You've gone too far.
Yeah. Story of my life.
You know this is all making a cut, right?
I'm leaving it you to edit it, mate.
Yeah. Don't worry, we've already got a plumber's crack. She's a little bit over still.
One's a little bit longer than the other.
Yeah.
Let's just trim it to the same length.
Yeah.
Did you allow for the distance between the two elements in the middle anyway?
Well, this is an interesting thing because none of the Moxon calculators or any of the documentation I've been able
Actually
to
tell you what the distance is at the feed point.
Yeah.
So we've worked on 10 mils.
I think
it matters that much.
No, I think the general rule of thumb is that you make it up with the bit of coax that's exposed anyway that you're attaching to it.
It's effectively zero with the coax, so it doesn't really matter what this is.
No.
This is just to the mechanical.
As long as it's not super long.
So we need to come back 50.
Come back 50 mil.
So that's where your bend starts, yeah?
Yep.
It's more than 50 mil. Okay, it's 50 mil.
It's 50 metric mil.
No, measure twice, cut once, or bend once. So what the boys are doing now is they're bending the reflector, which is the bottom bit. So they're the same measurements here. So you can see A is, what do we got? So this is for 50.150 megahertz. The diameter is 12 millimeters. So you put this all into a calculator. There's lots of Moxon calculators on the web. I'll put a link to this one, this particular calculator, or a calculator that you can use, in the description below. But so 50.150 is the frequency, 12 millimeters is the diameter of the tube that they're using. So you can just substitute that for whatever diameter wire you're going to be using. It gives you the wavelengths, it gives you the feet, inches. We use meters here, so you can see here, so the A measurement is 2.035 meters. So you can see here that's A. So obviously we mentioned before about the feed point. They don't take into account the spacing in here, but we're just assuming 10 millimeters. So A is the same on the reflector. Then you've got B, which is 0.301, which is the driven element bend there. So B, same too on the other side. Then you've got C, which is 0.5 or 0.58 or 579. That is the gap between the two elements. So that's actually pretty critical because that does affect the matching. D, 0.428, which is the reflector bend length, or length from the bend. And then you've got E, 0.788, which is the overall length from between each element, or the ends of each element. So, so they're bending up the reflector at the moment. Have we got it nice and square?
Pretty nice and square. It's not very well aligned, but it's somewhere near it. Let's go a bit more.
Looks good. So what are you doing at the moment?
Okay, so I'm going to put some nut certs into this piece of alloy plate.
Yep.
So they're pretty cool. These are aluminium ones that have got, I think they've got a steel insert. The trick is to do it and not actually do them too hard. It's real easy to overdo it and you rip the thread out of the insert. So it's a little bit of experimentation in getting it right.
So these are kind of like pop rivets. They rivet in there and they've got a thread in there so you can actually put screws in.
Yeah.
So rather than just having a bolt with a nut on the end.
Or to use self-drillers.
You got the thread in there.
Yeah, so you've got the thread in there. So they're a pretty cool idea.
We call them nut certs here in Australia. Not sure what they're called elsewhere.
Yeah. That's what I only ever called them nut certs. So.
Yeah. And then this is the other bit. So we're using these. There's a bit of debate about what these were called, but Stauff. Stauff clamps.
Well, that's how it's got Stauff, so I call it Stauff.
Yep. Stauff clamps, so they're going to hold the aluminium tube in place.
So 2 sets of those, and then the feed point will be right in between here.
And these Stauff clamps, you can get, we get them locally for a couple of bucks, but you can get them online at various. So there's some amateur radio yagi builders who use these and they sell them, so you can get them from them.
Yep.
But yeah, you can do some research if you just do a search for, if I can get it in the sun, Stauff. Stauff clamps, and they're just little hydraulic clamps.
We've got the boom.
Got the
so
boom.
Just do a little bit of drilling.
Oh, so okay. So what we've done with the boom is you've just got a bit of aluminium angle.
50 alley angle. Yep.
Some angle, and you're just going to mount. So that's going to be the feed point, and then we're just going to have a single
one clamp at the end. Yeah, just
single
just
clamp.
One clamp at the end just to hold it.
And then basically, so that's the other thing, because this is on 6 meters. It's a 2-element yagi. It's not a very big boom at all. It's very, very small.
So
and then you just have a U-bolt
so
in
just
the middle
a U-bolt,
clamp.
sort of like this, sort of in the centre.
Yep.
Which will basically be to attach to the mast. At least when we test this antenna, there'll be no trouble at all to get it a wavelength off the ground. Just put it on the thing and.
Yep, that's true, because we can put it on top of the hydraulic mast, which is on the
field day truck.
Field day truck.
Get a bit of a cheap plug-in for the field day truck.
Everyone knows the field day truck.
People think it's yours.
So you've got this is a recurring theme in videos, isn't it? You've
Seems
got
to be a bit of a.
Yeah. So what's your shirt about?
It's all about Pythagoras, but talking about the hypotenuse and a bit of trigonometry. I think it's quite apt.
Well, it makes maths fun, right?
Yeah.
I don't know. Mine's I go chasing waterfalls. FT8. You can get these shirts at hamtactical.com.
Okay, mine was just from Redbubble.
Oh, okay.
Free plug.
So, now we're at the stage of we're just mounting bits to the boom, which is just out of shot. So, you've got one clamp on there.
Yep.
We're just organising the second clamp, which is
we're just going to put.
Which has eluded us for a minute.
There it is over there.
So, yeah, so one clamp at one end, which is going to be holding the reflector.
Yep.
This is going to be holding the driven element, and
feed point will be right there.
Feed point will be right there. Now we had a bit of discussion about balance, didn't we?
We did.
We're not quite sure what we should do for a balun with this. We had a couple of options. One was
like an air balun.
An air balun, so ugly balun choke on a bit of PVC.
Yep.
There's also a toroid. So I've got some toroids as well.
Yep.
But I mean, it's going to be this is going to be mainly operating in the field day van, so we're not going to be operating from home. So, you know, maybe what we'll do is we'll look at
got some clip-on ferrites as well. Maybe just put a few ferrites down it.
Yeah. Well, we might. That's just to remove the common mode current off of the feed line, so we don't get RF back into the operating position, all that sort of stuff. But because we're a little bit loose and she'll be right. I reckon we'll just go with the air core first and see how that goes. Just
try the air core and just see how it goes for a match. Yeah.
Because they are fairly critical. You got to make sure you get the right amount of turns and all that sort of stuff. But we'll do it. We'll see how we go. But yeah, she'll be right and she'll work. It's only 6 metres after all.
It's only 6 metres. A recurring theme.
A recurring theme. We've had a boo-boo already.
Oh no! You put the markers on me, Hayden.
Where's it gone? There it is. Oh no! Well, we did mention that earlier, and I said you should check.
Make circular polarised versions.
Circular polarised Moxon.
It's a relatively big job, I guess.
There's the old life lesson. Now we make sure. Yep, the nutserts are on that side. Yep, cool. I think we're right now.
Gee, Hayden, that's a vicious outburst.
It wasn't my fault. It's all right, Tricky. You're probably not the first person to put a PL259 plug together and forget to put the outside ferrule on before you actually do it. And it's like the most perfect connection, the most perfect plug you've ever put on. And then you look down, you're like, oh, come on.
That's right. Well, hands up those that have put any sort of connector on that's got a shroud. Yeah. And not put it on. And like, I can still remember once at one job I was at, we soldiered a 13-pin connector on. And like heat shrinked every single one of them, and then went, whoops! There's the back end. It was one of those C9 or those C13 mil spec things.
The only problem is it's just 2 holes, so that's fine. No one will ever know.
No one will ever know.
We'll cut this out in editing. It's all fine. So what's the point of 6 metres? Is there actually going to be anyone on 6 metres? Does anyone Does anyone frequent 6 metres? Is always the question that I get. I get told 6 metres is dead. There's no one ever around. But we're starting to come into spring here, so sporadic E will start to fire up, and we'll get some 6 metre stuff happening.
Well, I think there's been a bit of activity around on FT8. It's just a matter of sort of being there. Like the age-old thing with 6 metres, isn't it? You just have to be there. You just have to have the radio going. You have to be there.
Rough as guts. Don't need a drill press. All good.
No drill presses here.
No drill presses needed. Typical Australian antenna. Should be right. Might require a bit of modification.
Give me the clamp. Give me the clamp. Let me go and get one of the ones that's smaller in diameter.
Really?
Well, the thing is, there's ones that are 10 mil shorter here, and they're slightly skinnier.
I marked it off the clamp. I think that's relatively close.
I think that's pretty good. Right, back to take 2 of the reflector, which horribly failed last time.
Well, it didn't horribly fail.
We've got the right clamp, we've got the clamps on the boom around the right way. It's going to come together. Once you put it together like this with the boom, it all looks rather small, doesn't it?
That's the idea. It's going on the field day van.
Yeah, which is good. It'll fold down nicely like the other antennas that are up there at the moment.
Correct.
You can make sure it's the right length. Is that the right length at the moment? Or
Don't know. I'm only doing one end.
Oh, okay.
Just so that we don't lose this up inside.
Yeah, yeah. So the idea with these fiberglass bits, this fiberglass spacer, is so that we can shift this in and out. There's supposed to be a gap here, a measured gap, but if you do adjust it in and out, you can tune it a little bit or somewhat.
58. Happy with that?
Yep.
Just a bit of tape to secure it. Then once you know it is 58, that's when you can lock it off for something a little bit more permanent. So, what we're going to do now is attach a bit of coax.
Yeah.
Which we prepared earlier.
Well, we haven't quite prepared earlier, but...
Well, half prepared earlier.
This is a bit of...
Silfoil RG58 coax.
It's really good, sort of nice and low loss.
Low loss.
It's one of those fun games, isn't it?
Unwoving the braid.
Well, this Silfoil is its advantage, of course, is that it's got the foil over the inner, and of course you need to
take the foil off as well as the braid. This is
decisiveness.
So this is Macgyver crimping, right? We don't have crimpers that suit this size.
It's not coming off of there.
Oh, look what you did, man! It's a bump on my finger.
It's all right for the test ones, but yeah, we wouldn't recommend it for permanent. So attach our coax, and then we can hoist this up in the air and see how it goes.
All is not lost.
All is not lost, as long as the washers are not lost.
Well, things could be worse, maybe we could be up a tower.
Yeah. Look, can you go retrieve that, please?
They're still making them.
$51.5, and we want it for 50.15. So yeah, it's about 2.2 to 1 down at 50.150. So yeah, we might need to do a little bit of tweaking, but that's okay. That's what we expect. And we have it plugged into a local beacon, which is not that far away. So you can have a look. We're pointing towards the beacon. That's about a S6, S7 on the meter. So for now, if we turn it in the opposite direction, and we watch the meter, that is now an S1 to S2. So it's lost about 5 S points. So pretty directional. Not too bad.
I just think we need to tweak the dimensions, either the spacing or even like the gap. We need to tweak that and see what difference it makes. We might even just need to change the spacing or We might need to trim a bit. Oh, we don't need to trim it off. We need to trim a bit on.
Yeah,
Trim a bit.
Make a new one.
We'll make a new one.
And I think what it is, we'll calculate the difference between having the element bent at 90 degrees, like a straight bend, and as opposed to having a radius. Probably going to lose a little bit, aren't we?
Yeah.
The way this is drawn is that it's drawn as a sharp corner, which is how you would do it.
Yeah.
But when we've used pipe or tube and we've bent it, we've obviously rolled it to a radius. So if we work on the centres, which is a nice easy way to do it, sort of 40 and 40 is basically 80 mil of material, but a quarter circumference of that circle ends up at 62.84 instead of 80. So we're sort of 17 mil shorter.
And that's on each side, right?
And that's on each side.
So it ends up being like 34 mil short.
So that's a significant amount, and that seems to sort of gel with your earlier calculations when you calculated for 5150.
Yep.
And then 52.525, it was like 30 odd mil difference. I mean, okay, this is 34 mil difference.
Yeah.
And now it's high.
Yeah.
So
Which means it's a bit short.
because it's resonant about 51.5.
The whole idea is that it's shortened, isn't it? So that's actually supposedly the driven element, and it's matching. Its impedance effectively is altered by the fact that this is nice and close, and this spacing is what it is.
Well, let's make a new set of elements. Make another one. We've got enough material on the ground here.
Plenty of material.
Plenty of material. I'm still making it.
All right. Well, I'll leave you guys with it, and I'll put a screenshot of your take a photo of your SWR measurement to see if it actually works.
Yep,
We'll do
will
it for
do.
you.
All right. If you want another 6 metre antenna that you want to build, then one of the easiest antennas for 6 is using just one piece of coax. Click on this video right here to go over and view that now.